Hi, I'm Shane Strubwick, CEO of Neotech Coatings Australia. We're the authorised distributors for Australia and New Zealand for SBI Coatings, based in Kansas, and we specialise in thermal insulation and corrosion protection. Up the top left-hand side, you'll see a time-lapse video we did where we took a chicken farm, it's a pump shed, from 38 degrees down to below 27 degrees. And the roof itself is around 47 degrees. That was receiving maximum solar heat. So you can see within a really short period of time, we can have a dramatic drop where we keep the substrate essentially near ambient. That's always our goal. So we know black is hot, we know white is cooler, but there's actually a lot more to heat, and it's really when it comes to infrared heat, which is our specialty. Here's some of our global partners. We've worked with thousands and thousands of companies over 35 years and all over the planet. So we do understand what we're doing with our products and solutions. And here's our green certifications and fire ratings. So for UL specifically, if international companies are looking for those fire ratings, we do have certification. We're Energy Star rated, LEED, and we're ISO. And we have also cradle to cradle certification with regards to our sustainable processes. So when the heat's on, performance really does matter. So since 1989, we've been able to utilise multiple ceramics in our heat block coating, but we also deliver some really outstanding other factors when it comes to applying Supertherm or our thermal insulation coating. So we provide energy savings and corrosion prevention. We give you personnel safety, asset protection, as well as carbon reduction. So passive heat is definitely our specialty. So Supertherm is super thin, so it's just 0.25 millimetre thick, and it's able to block 96.1% of the total solar heat when it's coming from the sun. So we fundamentally focus on the science. If you block heat and you keep it out of the envelope, then the rest of it becomes easier to manage and it's cooler inside. So essentially we bring the physics, the data, the science, and combine it to revolutionise insulation, and we'll explain how. So some of the really unique features and benefits of Supertherm is it blocks 96% of the total solar heat, blocks infrared heat. It has 4 different Class A fire ratings, including NASA, who's the only insulation coating to ever test it for fire. Because it blocks electromagnetic radiation, we're able to reduce sound, and we have ASTM testing on that 50 to 68%. And with the correct applicator and no dilution of the product, you can get well over 20 years when it comes to performance. Back in the 1980s, the space shuttle used to have a silica ceramic tile, and that was to really stop the re-entry heat of around 1200 degrees from going through the aluminium body. But there's a big difference when it comes to 1200 C at 10 minutes in relation to 40 C for 12 hours. So J.E. Pritchard is the president of SBI Coatings, and he's also the inventor of Supertherm. Back in the 1980s, he was selling and promoting solar reflective paint, but didn't quite understand what was going on. When he asked the factory, no one could explain it to him. Being a very inquisitive fellow that he is, he reached out to his uncle Redstone for NASA and asked questions with regards to the ceramics on the space shuttle. After he tested the 16 different ceramics, he then went back and realised that, okay, if you put them from a dry state to a wet state to a dry state, they won't work. So he went over and researched 4,000 different ceramics found around the globe. He was able to isolate 12, of which 4 are in Supertherm now. But the relationship with Supertherm and NASA has been going a long time. In fact, we only recently had a 35-year review with NASA in their spin-off magazine, and we're the only insulation coating in the world to actually have this level of relationship because our product works, and it works very, very well. This is Jay explaining emissivity and the ceramics.
2,000 degree torch, and we're going to put it right here in my hand. And we're going to hold it there. You can see the red flare from the heat itself. And we've already been there long enough for the heat to start coming through if it was going to load the heat and bring it through to my hand. But what's going on here is that this particular compound physically does not have the density to absorb and hold heat. So it throws it back off to the atmosphere that's cooler than it is. And it does it very quickly, as fast as it comes into it. So one of the things that we want to also demonstrate is when I take the heat off and you see the die down of the red.
So what Jay was demonstrating there was emissivity, but he's also demonstrating that not one compound can block all the heat as well. So while that was working to not load heat, there's still the need to deal with the visual side of it, with the UV and with the other infrared elements that are on the wave. So we'll go through that, but no one compound blocks all the heat. Quite simply, if you have electrons that can move faster and faster across the surface, they will transfer and they will get hot. And the hotter they get, the faster they move. So what Supertherm does is it neutralizes the capability for those electrons to transfer. And the way we do that is we work on a very different insulation principle to traditional bulk insulation. Ceramics are known to cluster form almost like a vacuum base, and then as well as they create a barricade. So heat's not able to transfer. There's no air pockets in there, unlike fiberglass, which is just all air. It's about resisting the heat. The faster the heat transfers through the insulation, the hotter it's going to get, where ceramics resist that. So there aren't many properties in the ceramics that can be achieved in a synthetic form, which makes them highly unique. They're super tough, they're inert, they're natural, and they don't use air to slow heat down. So ceramics are used all around the world, and they're in your phones and in your computers and used in every industry pretty well when it comes to some sort of thermal management. So they are super important and they're super functional, but you have to know which ceramic is doing which with its properties. We're opposite to the way insulation has been traditionally promoted around the world. Insulation was originally tested in 1977 on 3 inches of fiberglass in a lab and was only ever tested at 23 degrees. So 23 degrees is the optimum human temperature ideally. In reality is we need insulation that can cope with 40 degrees, 45 degrees, but you won't ever see that. So the air will transfer through quicker, the R value is going to drop, therefore it doesn't help when it comes to promoting what traditional insulation does. Supertherm and thermal insulation coatings do it opposite. We don't use air in order to resist transfer. We use the physics and the science within the ceramics to block the initial heat load, and then only a minimal amount of heat is allowed to transfer because there's no air. So you'll quite often find on ceramics, it'll be a linear scale of the way temperature goes up and not a curve. So while traditional insulation, including aerogels, are only tested around 23 degrees, that doesn't give you any real indication because it's not tested in the field, it's not tested with moisture, it's not tested with dust, it's not tested with compression. We've been tested at 100, 75, 50 and 23 degrees and performed the same the whole time. And this has major benefits. So when it comes to the sun's heat itself, most people don't quite understand how the heat is broken up into with regards to nanowaves. 43% of the sun's light can be absorbed as heat. It's not actually heat though, it's visual light. So the darker the surface is, the more heat you'll actually physically absorb, hence why dark colours are hotter than light colours. But what a lot of pretty much all paints in the world can't do is stop and block infrared heat. That's a completely different heat. That doesn't rely on being white in order to work. When we look at the atmospheric window, we now know that 54% of the heat is from infrared heat. Well, Supertherm can block the UV, most of the visual, and pretty well all of the infrared heat, but it also heads back out as a radiative cooling because it goes out cooler than it comes in, and so it goes straight back into the atmosphere again. And really that's like the golden goose, the product that blocks most of the heat and reflects and returns most of the heat to the atmosphere as well. And as we'll see later, there was a study undertaken by the University of Adelaide. Supertherm demonstrated, as it does globally, it's much cooler above the roof. So there are 2 types of ceramic insulation coatings. There's thin, which block and reflect heat from the sun, and then there's thick, which contains and holds heat on the surface. So if we first look at our closed ceramic thin insulation coating, which blocks the heat, now we understand UV, we understand infrared visual, we also understand that thermal emittance is the ratio of heat that's let off the roof or off a surface. So all coatings are rated against an SRI, which I'll explain later, but their emittance, so it's how much heat they hold and how much heat they can release quickly. And then the third one, which we're most interested in personally, is the thermal transmittant. How much is actually going through? So it's similar to working with a pipe. If you have an internal radiant surface area that's hot, you want to keep that heat in. So our HPC can go over that and contain the heat in, so there's less heat and energy leaving, therefore there's less cost, and you get a better cooking process, whatever's going through that pipe, and it's safer. So cool surfaces really are a blind spot. When we look around Australia, around the world, we see how underprotected we are when it comes to dealing with thermal heat and when it transfers. And we have a lot of challenges with regards to reducing the urban heat island effect. Heat also has an impact on humans as well as animals, particularly with heat stroke, and includes mortality, morbidity, labour productivity, infrastructure and critical services. The forecast for Perth into 2050 is going to be an increase of 9 days above 35 degrees if there's no further action to climate change and carbon emission reductions. However, it's way up north in northern Western Australia where the heat will be of significant impact, and they'll be reaching another extra month of temperatures above 35 degrees. We also did a bit of an economic study for Department of Communities in Perth, and based on 42,000 community homes, we calculated by putting Supertherm across the roof, you could get $173 million in saving by not replacing a roof. You're extending the life. You're reducing the healthcare because people aren't getting heat stroke. You're also getting a 5 times benefit by applying cool roof coating. And APEC did a study. There was a nearly $4 billion savings in kilowatt energy by having cool surfaces. And we also did a carbon conversion, which is equivalent to 2 million tennis courts of natural habitat being replanted by having cool surfaces. Now we measure heat based on BTUs. It's how much energy your air conditioner uses to remove heat from a building within an hour. So Supertherm had been tested with a thermal diffusivity test, ASTM test, and our goal was to distinguish how many BTUs the coating reduced in transfer, which has got to do with the conductive heat. The unprotected plate was transferring 367 BTUs per hour, and the Supertherm came in at 3.99, which is pretty much 0.5%. So by the mere fact that when you're blocking that heat, infrared heat passing through, therefore it's cooler on the other side. And you don't get that from R values and you don't get that from K values, but you can get that from thermal diffusivity. So if we're to take some of those BTUs and put them in a fairly simple calculator, we can see an average home have around 60,000 BTUs an hour. They'll be using 17,000 watts or 5 tonnes of carbon. And similarly on the right, which is equivalent to a shipping container with no insulation, is 19,000 BTUs, 5,500 watts or 1.6 tonnes of carbon being used per hour. So insulation matters in order to keep things cool. And even if we were to look at ColourBond's solar absorption rates, their lightest colour, Dover White, which is solar absorption around 28%. So they're still a long way off of being able to stop the infrared heat. And unfortunately, when you look at the darker colours of Monument, Night Sky, it was a ridiculous amount of heat being pulled in, because we do know that visual light is 43%. So the lighter the colour you go, the less visual light you will absorb. But if we're to compare Supertherm with ColourBond, similar colours, our surf mist comes in cooler, and then it goes on and on from there. So you can see the major difference by blocking heat. It's still drawing the heat in visually, however, blocking the heat makes a major difference. So the key heat for us is thermal transmittance. It's how much heat can we stop transferring. You'll find in general SRI or solar reflective index marketing that they won't really discuss ever about solar transmittance. So they're very interested in talking about reflection, they're talking about emissivity, but they won't ever tell you and can't ever tell you what is actually being transmitted. As an example about the solar reflective index, Purdue University recently put out what they claim was the world's whitest white paint, which actually reflects light, not heat, as we've explained. However, what they also inadvertently declared was the fact that the coating doesn't work very well on walls, however, because it can't stop the infrared heat from the hot pavement, so they have to use a different product for that. That 100% clearly explains that they rely just on reflection, making it as white as possible to reflect the light, but they are unable to stop the infrared heat, which is exactly what these coatings should be doing. To stabilise a substrate, you must stop the heat. because this is the way they test it. They test it against a black box. So they know 100% of heat loaded and 100% of heat emitted. And they have the instruments taking solar reflectance off the surface along with the emissivity of how much heat is being emitted. But no one can tell you how much heat is transmitting, which is really the ultimate goal. If you're not stopping the infrared heat, you're not stopping more than 50% of the heat. See, solar reflectance, that's why people want to go whiter and whiter. And a way to demonstrate that is, we always use a car as an example. If white pigments were to stop all the heat, then the bonnet or the hood of the car would be near ambient temperature, in this case 35 degrees, but it's not. It's 42% hotter as a white car. So the density in the metal, the infrared heat, is being heated up. It's gone past the white pigments and then it's transferring through. So if you block the infrared heat and then adjust your color, then you actually have a fantastic way to ensure that you don't get heat load on any surface. And the other downside with solar reflective paints is they do lose a lot of their reflectance in a very short period of time. We've seen warranties where people say you need to keep the roof clean. There's all these things because they rely on being white, because they can't block the infrared heat. And there's plenty of studies to show that. And even the solar reflective index test is only for 3 years. And you'd want certainly a lot longer than that for the investment you're putting into a surface. One of the joyful things I do is demonstrate Supertherm on a hot day. So this is me standing on a roof 0.25 millimetre thick. It's 38 degrees and the roof next to me, the unprotected, is 56 degrees. And you can see how much cooler my shadow is, but also how much cooler the Supertherm is over my body. So it's a really interesting demonstration that you'll be safer with a cool surface of Supertherm. We recently did a series of shipping container restaurants where within one coat we were able to reduce surface basically to ambient. And that was quite amazing, particularly for the staff inside the restaurant. Prior to that, they only had a small roof space, no insulation except for the 50mm PIR, and that was really hot, just as hot as the surface. So after we sprayed, we took the average from the roof space at 65 degrees down to 34 degrees average, which was well within ambient. And then also the kitchen staff went from 38 degrees, in fact there was a 40-degree temperature we recorded in there, down to a very manageable 26 degrees. So if you knock out the heat at the surface, it's not going to transfer, then you can just work within the ambient temperatures, which is primarily where your heater, your insulation, and your air conditioning can work as well. This is a fantastic example of when you stop thermal heat load on a mass, a thermal mass, in this case concrete, how the concrete will actually be cooler than both the ambient and the other surfaces around it. So after this house was sprayed, we took infrared readings from there, and you can see very clearly how much cooler the concrete is over the tiled roof next door, the trees even, and clearly the white roof, solar roof down below. So we're talking it was more than 20 degrees hotter on a white roof next door to it. So as far as being cool, now that entire thermal mass of concrete is now stabilised, and it is the coolest concrete in that area. Therefore, it reduces the urban heat island effect. The US Department of Energy have tested Supertherm in 3 locations. In fact, it's the only insulation coating they've ever tested like this to validate our claims, and it was 100% accurate what we say. What was particularly interesting in this test was how much humidity was, it was how much drier it was with regards to its humidity inside the container. If there's less heat and there's the moisture's in there, the moisture isn't going to heat up and become humid. So we had testing done in both Florida, Denver and Texas, which is all found on our website. And heat works the same all around the world. We have distributors worldwide. We deal with worldwide thermal insulation corrosion issues, but you can see whether you're in Mexico, South America, Europe, Africa, Asia, it works the same. We recently won a EPA award for our thick insulation coating HPC. Now, Georgia Pacific engineers did a 2-year review with regards to using HPC. They trialled and tested other products and they chose HPC to do on a digester tank. They calculated that they had a 49% energy saving and an estimated $330,000 saving over a period of 1 year. If they were to look at the return on their investment, that took 11 months to get a return. The project data was captured over 2 years, and the end result was a significant saving. So now they're going on to do all their tanks across all their sites in the USA. We're surrounded by thermal mass in our buildings, in our homes, and our environment, and everything's hot, really hot. You can see here from the Western Sydney University, who we do work with, a black tile roof is far hotter than a white metal roof. So let's explore this a little bit. So thermal mass is basically heat absorbed into whatever materials are capable of absorbing heat. And regrettably, tiled roofs, metal roofs, concrete roofs, brick walls, cement walls, everything essentially absorbs heat unless it's blocking it. If we're to take this tiled sample over here, it was only just a 22-degree day. At around 12 o'clock, the Supertherm was 26 degrees, and that's because the heat was inside the roof coming back underneath it a bit. The actual unprotected tile was 60 degrees and was physically burning my hands when I was doing it. So if you keep that thermal mass out, you're in a better position. But the problem you get with thermal mass is the fact that it affects everything. Insulation cannot stop thermal bridging. If you have a hot surface and you have metal frame all through the home, then all that heat's just simply transferring through the home, and there's zero that insulation can do to stop that. So regrettably, if you have extensive thermal bridging, you'll also get a high heat transfer within the home in next to no time. But the unseen negatives of all this is the fact that there are roof assets or other assets that can be affected by all that heat, that conductive infrared heat. If we take air conditioning ducts, for example, I've seen systems running across 15 or 16 metres, getting within 30 centimetres of a 60, 70 degree roof. None of that makes sense. And you can see if they think that foil and R1 insulation is actually insulation, it's not. It's not doing hardly anything. In fact, all the heat is being lost in winter and the heat's being penetrated into it. The air conditioner has to work hard, and people who can't even get access to that nice, cool or warm air are essentially unprotected to a large extent. So all your assets, including your electricals, insulation, ducting, whatever you have sitting in the roof, if you don't have any envelope protection, everything is getting smashed by heat. And that's an important factor when it comes to how much heat is being absorbed into the home. So colours do make a difference. Even when it comes to the building code, they've outlined across all climate zones except Alpine that if you have a darker roof, you need more insulation. The next step is to understand infrared heat, and then if you get to that stage, then your insulation is really going to have an opportunity to work in high heat. Regrettably, while there is a myth out there, you just add more insulation, R values are not linear, so you get very little additional benefit when it comes to just putting more insulation. In fact, one of the real downsides, if it gets additional moisture in it, is that the whole roof can collapse. So the important thing is you can run on minimal insulation if you're keeping the heat out, and the insulation works on reverse, keeping the heat in winter. The other regrettable part about a warming planet is the projection by 2050 that there's likely to be more than 4.5 billion air conditioners being used. Air conditioning systems generally after 48 degrees don't work efficiently at all, and beyond 35 degrees they start to cost 2 times as much to run. So you're running in a hotter environment with less efficiency, burning up more carbon and not getting the results that you need. One of the interesting tests we did was on reefer trailers running between Phoenix and Denver. After Supertherm was applied on the reefer containers, there was instantly a cool down time of 1.75 hours, which is 44% faster. There was 20% less fuel used on the outbound or the hot haul and 29% less on the cold leg. So they've actually saved more money on the colder run than they have on the warmer run because the cooling doesn't need to work as hard. The other really interesting thing is it paid itself back within a year. So if you were to look at a series of 300 reefers, you could be over 20 years doing $54 million savings in fuel. So by keeping the heat out, that comes from the bitumen and everywhere, you're going to save money.
We approached the City of Adelaide regarding our idea of a cool roof pilot to be published following on from the Cool Roofs trial. The council wanted a cool roof pilot to share with their community, developers and partners in relation to adapting buildings and the city's climate change. They also wanted to understand the impacts and the benefits of cooling urban heat in the Adelaide City area. 2 buildings, including the netball club rooms in the parklands, were protected with Supertherm. The infrared images from the unprotected dark blue roof were crazy hot. On only a 25-degree day, the roof was over 50 degrees and would get much hotter. The infrared images show a striking contrast of the cool performance of Supertherm over the unprotected roof. What's important was the results. Our summary of the report is phenomenal. Firstly, there was a significant reduction over the dark roof as expected. Secondly, it showed nearly ambient temperatures just above the roof, and below the roof was just below ambient. As aligned with other reports, this is offering significant thermal benefits in the summer with minimal impact in the winter. And when it gets really hot, the building is substantially cooler during heat waves inside. That's huge, as we're cooling the environment and cooling the inside of the building at the same time. It's cooler than the trees. On request, we believe the City of Adelaide will distribute this amazing report with just one 250 micron coat of Supertherm heat block insulation coating. You've achieved these results. That's phenomenal. And when it comes to reducing urban heat islands, it pretty much outperforms every other product in the market.
We have a lot of global projects, and I'm just going to run through a few of those here. So this is the Tucson Airport, where they calculated a 22% energy saving across their airport after Supertherm. All the air bridges have been painted in Las Vegas, and after they did their tests and trials, they decided to go with Supertherm. They were very impressed with the ambient temperature of Supertherm in an enclosed jet air bridge. So it was with 1 degree of ambient, and as we know, Arizona gets very hot. This entire casino boat ship was painted in all the SPI coatings, including Supertherm for insulation and rust grip for corrosion. So they didn't install any other extra insulation. They painted the outside and the inside to regulate internal temperature. Supertherm is used on LNG tankers as well as plenty of other marine craft in order to reduce heat transfer. So whether it's in the bridge or accommodation, or you can be used in engine bays to both keep heat and noise in. Being able to apply with our corrosion product Rust Grip while you're sailing across the ocean is a significant saving when it comes to dry dock expenses and operational costs, as well as performance. The Middle East have used Supertherm since the 1990s, and clearly it gets very hot over there. So one of the interesting case studies that we followed up on were these propane tanks in the UAE. When propane gets hot, these aluminium skins are allowing a lot of heat to come in, conduct that heat, transfer in. It's heating up the gases inside. It wouldn't matter if it's fuel or anything. It heats up the gases inside, it creates pressure, and then they have to release the gas. Now the gas therefore has an impact on carbon emissions and safety. So by applying Supertherm, they can dramatically reduce the internal temperature of the tanks. And this was triggered by their safety office concerned about how much potential propane was being leaked. So they were very much focused on safety, and by reducing that surface temperature, they got a net benefit of carbon savings, safety, and they're also not losing products. So they actually can keep more profitability in the company. This is a data center wall that we painted. Now, it was a standard brick wall that was quite hot. It was in the 50s just on a 30-degree day. After we painted the wall, the surface became like ambient, and it also mitigated all the heat risk of heat transfer because the alarms were going off, the heat alarms were going off inside the building. Therefore, the computer systems were struggling to cool down, and we were able to eliminate all that with just a coat of Supertherm. What's also really interesting here is how much the white of the white cars. So we don't rely on being super high white, super high glossy in order to perform, because we're blocking that infrared heat. So we don't have as much visual impact, and that would have been seen with the City of Adelaide trial with the netball court building. We're specialists with shipping containers. We've coated thousands of shipping containers around the world, and there's only generally 3 or 4 millimeters of steel, and we're able to block all that heat getting in. Therefore, we keep that space near ambient. This is an award-winning project we did for the Hoover Dam, and this was primarily about protecting the asset with rust grip, then safety with regards to tourists leaning on a very hot surface, which is no longer hot, it's ambient. And then we had our sealant enamel grip for long-term durability, and we won an award for this project. We've done a lot of work with the US Defence with regards to down near Tucson on the air bases down there, who particularly under extreme heat in Arizona, and had major success with regards to keeping things cool, including other elements where we're able to protect aircraft, we're able to protect buildings, we're able to protect pretty much every surface possible from loading that heat. The Japanese were really quick to pick up on this technology back in the 1990s, and since then we've applied over 9 million square metres of Supertherm, or cool therm they call it in Japan, and across some of the world's biggest corporations. So sustainability was an important part of what the Japanese vision was for the future, and Supertherm became an integral part of that sustainable future. As an example of that, the Sony factory supplied to us their kilowatt savings in 1994, 1995, and there was, across those 2 years, there was a 75% drop in kilowatt usage because they didn't need to cool the surface. That makes a major difference to their costs and carbon. So as I explained before, we use BTUs to measure and to verify or quantify the value of Supertherm, and it's a fairly straightforward formula from ASHRAE, where they can take the BTUs, convert it into kilowatt savings. Just a couple of quick interesting things. Zinc aluminum, because it's reflective, does not give you any thermal insulation benefit. In fact, it's one of the worst emitters when it comes to heat. It holds heat on the surface, therefore it gets really hot. It looks cool in infrared because it's got silicon and alloys which create reflectivity, but as we can see over time, once those all break down, oils are gone, then it really does show its true heat underneath. Supertherm and PV panels are fantastic mates. They work really well together. Because we block heat, we protect battery systems, but we also keep the surface cool. When the surface is cool, the micro switches work better, and therefore you get actually more production out of your panels. Application is really easy by brush roller or airless. There are some few little things to follow, but airless is the easiest way. However, because it contains a lot of ceramics, we do have some specifications when it comes to the actual application, and the textures do vary. So in a nutshell, Supertherm is a single component water-based coating. It was designed to block heat. It's been thoroughly ASTM tested. It has multiple fire ratings. It's approved by the US Department of Agriculture for handling around food and for potable water, and you get well over 20 years if applied by an applicator that's trained and you don't affect the coating itself. In the real world, this is what we cover. We block heat load from the sun and from pipes. We have fire protection. We reduce energy costs and carbon emissions. We eliminate CUI or corrosion under insulation. We therefore save on maintenance and repairs. And our corrosion coating rust grip removes the need for the traditional 3-coat system blasting that has zinc. Our product is an aluminium polyurethane. It outcompetes pretty much everything in the market. We have a range of specialised coatings with regards to heat, sealants and corrosion and general sealants, so contact us anytime. We provide a great range of solutions for many different industries, particularly in tough environments, because we're specialists in thermal insulation and corrosion protection. Really, our end goal is to help reduce heat load, provide safety, and reduce energy costs passively. There's a lot more to heat and solar reflective paints than just SRI. It's important that you focus on heat load and heat transfer if you want to save money and if you want to future-proof yourself from a warming climate. Supertherm is absolutely brilliant for what it does, and it makes a major positive difference and win-win-win all around the planet. So in the end, cooler surfaces do make sustainable sense. Thanks a lot for your time today. I really enjoyed presenting that. I hope you got a lot of information with regards to understanding how heat's managed, understanding some of the different standards that are out there, understanding also that an open cell traditional insulation is really only tested at a lower temperature value in relation to Supertherm tested at over 100 degrees. So if you would like more information about the coatings we talked about today, including HPC and rust grip, please reach out and contact me on LinkedIn or visit our website neotechcoatings.com or neo.cool. Thanks for your time once again, and have a great day. Bye.